Okay, rates of change in polynomial functions, which hopefully is at least a familiar name for a topic where you're like, okay, rates of change. I don't know if I remember any of this. I know, that's why I came today, so that I can remind you how rates of change works. Yeah? Okay, so a trip down memory lane. Look, it's actually memory lane. Memory lane, a trip down memory lane. In this lesson, we will solve rate of change problems that involve polynomial functions. You already studied in chapter 2 the concepts of average and instantaneous rate of change in the past. This lesson will serve as a review and an opportunity to apply some of our knowledge about polynomial functions. The following functions are to be done on a separate page, so I'm not going to continue on the PowerPoint. I'm going to go to Active Inspire here and do them on here. So even if you don't have the note, what do you care? You barely had to. It barely is an advantage to have the note. You just want to be copying this stuff down. You have your choice coming up in just a minute. Not the first one. You got to do the first one. The second one, you got a choice. A rock is thrown off a cliff. The height of the rock above the ground in meters, t seconds after it is thrown, can be modeled by the following function. H at t equals negative 5t squared plus 10t plus 120. Determine the rock's average velocity from 2 seconds to 5 seconds. If your memory is good and you're right with me, you're like, didn't we already exactly do this? And the answer is yes. I'm going to review it here because I'm going to review it again next chapter, and I'm going to review it again the chapter of that. So it reminds you of transformations. It just keeps coming, and we want to make sure it stays fresh in our brain. So come exam time, if there's one question we can do average and instantaneous rate of change. But I'll teach it like you completely don't remember it at all. Like you can't remember anything I said about it, and I'll go right back to sort of the essentials of it so that here's another chance to learn about it. So average rate of change. Velocity average equals average rate of change. I did not have to write that. I just wrote it to maybe trigger a memory in your brain like, oh yeah, AROC, average rate of change. I'm going to write all the lines for you, just in case you've lost it. All the lines were, for average rate of change, it was just y2 minus y1 over x2 minus x1. That's all we were doing was slope. And those are horrible choices for letters in this question. I should not be using y's and x's, but that's just to trigger your grade 9 brain and go, oh yeah, just slope. Really, I should be doing height at 2 minus height at 1 over 2 minus 1. That's what, over t2 minus t1. Or maybe you're thinking delta h over delta t. That's what I'm doing, is delta h over delta t. These things are all true. You don't have to write, you should write all of them for the note today. When you go to do the homework, you don't have to write all of these. Maybe the really good one, the best of the bunch, is this one. Find the height at 5 seconds, subtract the height at 2 seconds over 5 minus 2. Okay, that's the one. That's where we were trying to get to in chapter 2, where you go, okay, find the height at 5 seconds, subtract the height at 2 seconds over 5 minus 2. This is where I will skip a little bit of steps because in chapter 2, maybe you were still learning how to sub things into your calculator. How do I type these things in? You know, what function do I use? What button do I press? Hopefully, at least that's gotten better over the last few weeks. So I'm just going to get these answers. H at 5, negative 5 times 5 squared plus 10 times 5 plus 120. I get 45. So after 5 seconds, the rock was at a height of 45. Then I'm doing it again at 2 seconds. On my calculator, I can just scroll back, changes those 5s over to 2s, and now I get 120. Was the height at the 2 second mark. So over the 2 to 5 second time period, it went from 120 down to 45, all right? The bottom's just 3. And when I do 45 minus 120, I get negative 75. which hopefully is not surprising, and somebody can tell me exactly what that negative means in the question, but I get an average velocity of negative 25 meters per second. What's the negative mean in terms of the rock? It's over that time period, it went downwards. It went from a higher point down to a lower point. And so that's an important little detail in all this, is that these formulas handle all that. They keep track of it all for you. So if you plug them in right, you get the right answers. How do we do on reviewing average rate of change? Is average rate of change okay? Hopefully it is. It really was just the applications of what you learned in grade 9. You know, when you did y2 minus y1 in grade 9, you're like, oh, who's ever going to use this? This is stupid. And then you get to this, and you're like, oh, that's what it's for. That's what slope is for, is finding average rate of change. Any questions there? Okay, that wasn't the tough question in Unit 2. After the average rate of change lesson, everybody went home and went, yeah, no problem. This is great. Average rate of change. Instantaneous rate of change. The next question is, determine the rock's instantaneous velocity 3 seconds after it's thrown. From here on in this course, I do not ask that you do method 1 or method 2. I just say, find the instantaneous rate of change, and you can decide what method you're going to use. I'll show both today. I got enough time. I'll do method 1 and method 2. In this question, I'll do it twice. Once using method 1 and once using method 2. Hopefully, to do two things. One, to scrape the rust off your brain, but also to go, oh, now I'm starting to get that. Maybe I just memorized it in Unit 2. Now I'm starting to get what's going on here. Here's method 1. Method 1 was the giant chart. And using method 1, I want to know the velocity 3 seconds after it was thrown, so I need some intervals, some delta t's in that first column. So I'm going to go 3 to 3.1, and then I'm going to go 3 to 3.01, and then I'm going to go 3 to 3.001. And I'm going to hope that's enough. I don't really remember, actually, this particular question, whether that will be enough for the magic to happen. Well, it seemed magical the first time we did it. Hopefully, after you did it a few times, it didn't seem so magical anymore, because you're expecting what's going to happen over here. Am I triggering a memory here? You're expecting what's going to happen over here. So, I don't like the label on that. I'm going to change that label to interval. And so my delta H, I'll need two things to find my delta H. I'll need H at 3.1, and I'll need H at 3. Those two heights, because I'm doing 3 to 3.1. So I'll just punch that in my calculator. Oh, I've still got it on my screen. -5, 3.1 squared plus 10, 3.1 plus 120, 102.95. And H at 3, I just got to go back and change those all to 3s. Do it. 105. Now I can find the delta H. It was 102.95. Sorry, 102.95. Subtract 105 equals -2.05. And then the delta T was 3.1 minus 3 equals 0.1. And so my average rate of change column, which was delta H over delta T, would be -2.05 divided by 0.1 is -20.5. That's my first estimate. I think the answer is pretty close to -20.5. But if you remember this, you're like, well, it might be close, but it might not be all that close. So we better go at least one more to find out if this is really good. And so I do the whole process again, but this time I need H at 3.01. So So I go back and change all those 3's to 3.01s. You're like, oh, I already got rid of that equation. I can't go back. Yeah, this is why, as we got better at it, we went up here and did all this work beforehand. Get all that stuff in there so it's all taken care of. And I get 104.7995. Did anyone else get 104.7995? Yeah, that's good. So then when I do delta H, I'm going 104.7995. Subtract the 105. 104.7995. Subtract the 105. And I get negative 20.05. And I go 3.01 minus 3 is 0.01. And I do delta H, negative 20.05, over delta T, 0.01. Oops. Sorry, I made a mistake there. I got it way ahead of myself. Let me fix it. I had the decimal places all wrong over here. Negative 0.2005. So it's negative 0.2005 over 0.01. Negative 20.05. Are you home free? Negative 20.5, negative 20.05. Some people would be. They'd only do the third one because I forced them to on that first test. I said, do 3. Yeah? 2 might be enough for you to go, I know what the answer is. But I'll do the last one just to show off the method. That really, we wanted you to do 3. We really wanted to see that trend going through 3 of them. So I got to go one more time. H at 3.001. Sub that in. My calculator. I can go back up and do old equations. It's good. 104.979995. 104.97995. So I get 104.97995 minus 105 equals 104.97995. Subtract the 105. Negative 0.02005. And my delta T was 3.001. Subtract 3. And then when I divide those, hopefully then you're convinced. I see where this is headed towards. Negative 20.5, negative 20.05, negative 20.005 would be the next one. Therefore, velocity instantaneous equal to instantaneous rate of change equals approximately. We really were stuck with writing approximately. It really looks like negative 20, but we don't know for sure it's negative 20. But it certainly looks like negative 20 meters per second. What questions do you have about that process after all this time? When was the Unit 2 test? It was like in September. It could be a month ago. So it could be pieces that are troublesome. But what questions do you have there? So you can use method 1. Hopefully we agree. Slow and boring. Yeah, and easy to make a little mistake. You saw me make a little mistake in there. It's hard to concentrate all the way through method 1. So I'll do the exact same question with method 2, trying to convince you that maybe method 2 gets through this stuff a little faster. Question? That seemed to be where it was heading. 20.5, 20.005, 20.005, 20.00005. It certainly seems to be heading towards negative 20. Yeah? Other questions? Okay, same exact thing, a little faster using method 2. Method 2 looked like this. I always drew the same curve. I always drew the curve upwards. You know, all my notes have this curve going upwards. Maybe this time I actually should draw the curve downwards. It doesn't matter. It doesn't change what you do in the question, but actually this rock is going down, so maybe this is the more accurate picture. And then you get your initial point, which was 3 comma well, what was it? When I subbed in 3, I got 105. So I got my initial point of 3 comma 105. And the key to method 2 is going, I'm not going to announce what the second point is. I'm going to say it's t comma, and I'll figure out what the t's are later, t comma, here's the height, negative 5t squared plus 10t plus 120. And then I make what's called a secant slope formula. It's a formula for this slope here, this secant slope. So I go negative 5t squared plus 10t plus 120, subtract the 105 over t minus 3. And in chapter 2, I stopped there. I went negative 5t squared plus 10t plus 15 over t minus 3. And then you just plugged into that formula. You went, okay, now I don't need, I'm going to draw it like this. I don't need all this stuff in between, all those calculations in between. I can jump right to slope of the secant. And you can totally do that. Again, this chapter, I'm going to sub the same numbers in that I did in the previous page. If you sub those numbers in, I'll do it in a second. You jump right to the slopes of the secant. So you do the same process. It really is the same process, but you've shortened it down dramatically. But we can do even better than this. Take a look at the numerator. Now that we got chapter 3 behind us, hopefully you see something in the numerator. You can't see it in the video, but I'm on one knee, praying, begging, maybe I'm not praying, maybe I'm begging. I'm begging someone to see what can happen in the numerator. Vanessa, what do you see? There's a common factor. It's not just Mr. Todd torturing me. Apparently, it matters, these common factors. Now, you could common factor out 5. I know a little better that if there's a negative out there, you're better off taking the negative with you. And so what I end up with here is, I forgot the squared there. If you were copying me, I forgot the squared on that line. I was so wound up in my little begging, praying move. I forgot to write the squared there. So there's a squared there. And then this is t squared minus 2t minus 3 over t minus 3. And you're like, well, yeah, I guess that's better, Mr. Todd. You're pretty wound up about that. And I'm not sure that really accomplished anything. I guess it might be easier to sub into to do this, but I don't really see what's happening. What else do you see? Let's get a little help. Tools, spotlight, square. Does anyone see something else in the numerator that might factor? Can you see something? Does this factor? What are the two numbers that multiply to negative 3, but add? Well, that's not what I wanted. Gotta turn that off now. Turn off the spotlight. How do I turn off the spotlight? There we go. What are the two numbers? Mr. Ty, you're hurting my brain. Yeah, you can use that one. You can totally use the non-factored version. But what are the two things that multiply to negative 3 but add to negative 2? 1. And what did you say? Negative 3. Dun, dun, dun. If this is a movie, we'd take a commercial break right now. Something just happened. I'm switching colors. Do you see it? It cancels. That's where calculus starts, right there. Calculus goes, oh, mama. There might be more to the story than even we've found out. Well, there's method 1, there's method 2. This is on its way to what's called method 3 and calculus, which you can see here on the outside, where they're doing some awesome stuff. Like it is Going crazy now in calculus. Anyways, I get a nicer formula for m secant. Is it worth it? Is this easier to sub into than that? Sure it is. I might even be able to do it in my head here, folks. I'm going to try. Sub in 3.1. 3.1 plus 1 is 4.1. Times negative 5 is negative 20.5. Oh, mama. Look at that. Did it in my head. Well, you don't have to do it in your head. You don't have to do it in your head. You don't. Easier to work with, though. 3.01. 3.01 plus 1 is 4.01. Times negative 5 is negative 20.05. And then I get negative 20.005. And then I get m. No, we call it instant. Do we call it m tangent? We did. We called it m tangent equals approximately negative 20. We're not sure it's negative 20, but we're feeling pretty good about it that it's negative 20. Wow. There. Does your brain hurt a little bit? A little bit of headache? You're like, oh, here we go. And it's true. Here we go. That's exactly where calculus starts. If this is a really good school, I'd say, what do you want to do now? You want to do the last few chapters of advanced functions, or we want to just start calculus? And you could start calculus right there. Your calculus people are ready. If you've understood that part of it, you're ready to go. The rest of the course is just, let's get some more experience with some other functions so we're ready when those functions come up. Because look at that sign on the board over there. They are ready to do this with sign, to do this kind of stuff with sign. What you're seeing on the board right there, over there, is called method 4. It's one step more than this. Yeah? All right. That's not what we have to do. You could have totally used this one. You did. Most of you did in unit 2. You just subbed into this thing. A lot of typing. Pretty straightforward, though. Okay? Any questions about method 2? I will not force you to do both methods on this test. When the instantaneous rate of change comes, you get to choose which method you'd like to do. I can't remember. That was problem 1. I'm already done. I got 2A and B and we're done. Yeah, we're in the home stretch already. 2A. The graph of a polynomial function is shown on the right. Estimate the instantaneous rate of change at x equals 2 by inspecting the graph. What? Mr. We didn't have to do that in chapter 2 at all. We didn't have to just look at it and try and figure out what the tangent was. Like, how am I supposed to just look at a spot in the graph and know what the slope of the tangent is? Like, if it's over here, how am I supposed to know what the slope of the tangent is there? It's like going that way. You physics people know. Your physics teacher should be forcing you to draw these tangent lines on there and find their slopes. All right, that's fine. So how do I do this question? Well, let's find the point anyways. Estimate the instantaneous rate of change at x equals 2. So at x equals 2, we're right there. What's the instantaneous rate of change right there? Like, what would the slope of the tangent be right there? 0. Wait a minute. Okay, all right. We can do that one. All right. From a graph, we can do the instantaneous rate of change at max and mins by just looking at the graph there and going, oh, m tangent equals 0. That is, the instantaneous rate of change equals 0. So that's just a reminder about graphs. Given the graph, we can find the instantaneous rate of change there, as long as it's a max or min. That's where we left off in unit 2. I put that on the test. I gave you a point where you could find the max or min just by looking at it. Good? Is that okay? Yeah, it looked scary and then it wasn't. Yeah? One more. 2B. Or not 2B. That is the question. Is it good? Like, what have you guys been doing in English? Have you done Hamlet yet, or you guys are too good for Hamlet now? Hamlet? Yes? No Hamlet?
Short stories.
Short stories. All right. Hamlet's good. I'm a math guy. Hamlet's good. And his son hangs out with Winnie the Pooh, I think. You think that one over? It's really funny. Give it some time. Trying to give your brain a break there because this one's good. This one's good. Estimate the instantaneous rate of change at x equals 3. Yeah. Mr. Todd, I can't do x equals 3. Well, I could draw a tangent line, and then what do you want me to do? Just draw a big line and find its slope? If you're in physics, the answer is yes. But we're in math. We're going to do better. By first finding the equation of the function. You're going to find the equation of the McDonald's M here, Mr. Todd? How am I possibly going to do that? Look at, hear how happy they are? Like, he's going to find the equation of that thing. They're wound up out there. Woo! Maybe we've got a chance. Y equals. Tell me one of the factors of this thing, since I've got the zeros. X minus 2 is one of the factors. I think she's poached an easy one. I got to make a little more room here because something slightly difficult happens here. X minus 2, yes, that's a factor right there. This x minus 2 is a 0. I'll come back to that. I'll pretend I didn't notice that. What's the next? 0. 4, so what's its factor? Yeah. We skipped one, didn't we? We jumped to an easier one. And then we jumped to this one, which is easy too. X equals 4, so this is x minus 4. But there's another 0 there. At 0, what factor should be out there then? Just x. I sort of tried to protect you from that in Unit 3. I sort of went, well, we won't do too many like that, because that can be a little confusing that x out there makes it 0. So, it's good? Now. Oh, but this can't be right, can it? This is even degree. Because it's both down. Mine's odd degree. It's only got 3 factors. What did I miss? The squared on the x minus 2, the bounce. Trouble. It's even worse. We don't know what goes out here. And this graph doesn't do a very good job. Let me go back to the one on the PowerPoint. I think it's a little bigger, and you can see a little clearer a point on the graph. Do you see it right there? There's a point there. Up till now, I've been always making sure that and I think I'll still do it. When I put it on the test, I'll be like, I'll put a dot in that point going, look, it's a point. Because I don't know what A to put out there, but who's on top of this? Who's got this? Where it's like, oh, I know what to do. I can get the A. It looks like trouble. It looks like, well, how am I ever going to find the A? But somebody knows. What do I do to get this A? Yeah, just sub in 1, 3. It's actually not that difficult to pull this trick off. Sub in 1, 3. So I get 3 equals A, 1. 1 minus 2 squared, 1 minus 4. 3 equals A, 1, negative 1 squared, and negative 3. So I get 3 equals A times negative 3. So A is negative 1. Therefore, Y equals negative x minus 2 squared, x minus 4. Okay, that's a very good Unit 3 question. There was one something like that on your Unit 3 test. Okay, now I've got the equation of the graph. Good, done. Am I done? No. This said find the instantaneous rate of change. So I've got to do a Unit 3 question to get myself ready to do a Unit 2 question, which I'll do on the next page. One more time through Method 2, trying to convince you that Method 2 is going to save you some time. Get good at Method 2. It's much faster. But do you have any questions here? This went well. A lot of people got the 2/3, and the people who didn't get the 2/3 got mostly there, just forgot one little thing or something like that. This was a good question for us in the test. Went well. Okay. What we really want to do is instantaneous rate of change at x equals 3 for y equals negative x bracket, I've forgotten already, x minus 2 squared, x minus 4. You're making me yawn. Add x equals 3. Did I put add x equals 3? Yes. X bracket, negative x, x minus 2, x minus 4. Negative, yes, all is good. So I'll draw my little picture here for method 2. Initial point, 3 comma, I don't know what that point is. And then down here, x comma negative x bracket x minus 2 squared x minus 4. 3 comma what? 3 comma what? Is it obvious from the graph? 3 comma 3. Yeah, I can see that point right on there. It's 3 comma 3. Am I sure? Ooh, better sub in 3. Negative 3 times 1 times negative 1. Negative, oh yeah, it is 3. Okay, so you could sub it in. I mean, that's what we did last chapter. Sub it in to get the 3, but I can see it on the graph. 3 comma 3. So then my MC cant is messy. Negative x, focus, negative x, bracket x minus 2 squared times x minus 4, subtract 3 over x minus 3. Woo! A little bit scarier than last chapter. I need to tell you, calculus people, that if you multiplied out all these brackets, collected like terms, and factored, the x minus 3's would cancel. It works. Shockingly, it works. I don't think it's worth the work here. I don't think it is, because we know what to do. We just go x MC cant. I've got to do some crazy subbing here. You should try it out in your calculator, making sure you know how to sub these things in. I'll do it as well, and we'll compare and see how we do, okay? Okay. Mess. Negative 3.1 bracket 3.1 minus 2 squared bracket 3.1 minus 4 bracket minus 3 all over 3.1 minus 3. 3.759. Anybody else kept up with me? Do you get 3.759? Yeah, and then if I go back, I don't have to retype it all in again. I just have to change all those 3.1s to 3.01s. All of them. Oh my, there's a lot of them. I'll go left to right. Oh, 01, 01, 01, 01. Okay, 01. Not Owen. Owen. 01. Did you get 3.979599? It might be 4. The answer might be 4. I'm not sure. This is why we do 3 to make sure. Go up and change those 3.01s to 3.001s. Maybe you're faster than me. 3.99799599. I think I'm feeling pretty good. Are you feeling pretty good about the answer here? Let's just go back and read the question, make sure I answer properly here for the question. Estimate the instantaneous rate of change at x equals 3. Therefore, instantaneous rate of change equals approximately 4. Really looks like it's 4. If it's not 4, it's really close to 4. What questions do you have about that? Am I done? Let me look at my notes. Instantaneous rate of change, method 2, 1, 2, 3, B, done. Yeah, I'm done. Questions? Last chance to be on the video for posterity.